Hey guys, hello to everyone. It seems that I'm the only one who just joined this our first lessons of our elective R course, but it doesn't matter. I think I can do it. Okay, so for all of you just going to just willing to follow these videos, these recordings, and materials, let me introduce myself. I am Lumi Shipanik. I'm just an assistant lecturer at the Institute of Biophysics and Informatics for Faculty of Medicine. Very good you know me from biophysical courses or medical informatics courses. I do my doctoral studies here and also at the Department of Biomedical Informatics, Faculty of Biomedical Engineering, Czech Technical University in Prague. And this is like something like, let's say, shortened and online version of our elective course, which is like officially called Introduction to R Scripting Language. And this is like I would like to introduce a workflow, how I'm just thinking about it, what could work, let's say, because you know that due to Corona pandemic, there are in general problems to hold elective subjects. Some of them were totally cancelled for this year, and this is not like our case because there are some of you who asked me just to hold kind of, let's say, improvised version, at least an improvised version, due to their needs of credits. I pretty understand this, and I'll try to do this kind of recordings. I'm just going to talk about it a little bit more later. But yeah, so for today, I'd like to talk a bit about organization and about some very introduction to our language and our environment, and about some data structures, data types, and things like this, stuff like this. So I'm just sharing my screen. So in the video recording, let's hope the video will be successfully rendered, because there's a usual problem. For example, I just rendered video record from the previous run for Czech parallel, and there was a problem with, let's say, last part of the video. So, you know, because of long videos sometimes crashed during the rendering. So let's believe it will work well. So for today, I think that okay, there's like the slides and the codes and the links to videos which I'm going to share at YouTube. I guess maybe the most cover for both sides. They'll be on a GitHub repo. I'm just going to show you what the link will be. And due to the fact that it will be shared on a publicly available repo at GitHub, I have just included it colophon in this slides. Okay, it means that in case that you would like to share the slides, the codes, or whatever, please know that you should indicate me as an author. But yeah, I'm not so much aware of this, but it should be done this way because of the license. If we are going to make any derivations of the slides and so on, then you shouldn't share it like, and this is like a bit restricted to share in case that you are going to manage it, for example, or transform it, for example, by doing some by doing any changes by yourself. So it also, the last thing, that it shouldn't be I think that it's not a problem because no one is going to buy these materials from you, but it shouldn't be like used for any commercial purposes. Yeah, so it was just for interaction. Yeah. Well, now let's look at the outline of this session. So I'd like to start with an introduction what our language is. Then we are trying to install it. I suppose that some of you maybe already installed it before. That's great. Then we just slowly move to data types and data situations, which are very crucial parts what you should be aware of, because once you understand how the numbers and the values and variables in R are coded, then you can simply use some, let's say, more advanced functions or any methods which are implemented in R. You can use them, let's say, very effectively, because yeah, this is very important to know about how the data are coded, how they are interpreted, how they can be let's say treated in our language, our environment. So this is like the main topic of today's session. So data types, data structures. Then I will talk more about vectors, which is some kind of basic one-dimensional kind of data structure. Then I'll just talk about some operations with the vectors. And finally, I'll talk about matrices, because next session we will start with some, let's say, more advanced data structures, which are made like data frames and lists, which usually, especially the data frames, are based on matrices. So if we try to understand how the matrices work in this session, it could be pretty easier to understand how to use appropriate format for coding of real data, real world data using a data frame format. I'm just going to talk about it next session here, but just data frame. It's based on metrics. I'm going to talk about metrics this session at the end of the session. And yeah, so this could, if we are going to translate what a matrix is, how it works, then it could be pretty easy for you to manage everything about data frame, which are the appropriate formats in R, how to handle with real world data. And yeah, so this is important. And I think about data frames and lists, I think it could be done in 30 minutes at the beginning of the next session. And then we'll move to some interesting stuff like some workflow controls like cycles, warnings, if-else conditions, some more programming stuff, and some functions defining import, export, input, output into R and from R to for the device, hard disk, and so on. So yeah, this is stuff. So for the okay, so for this week there should be 3 sessions. I hope that I'll be able to handle them in its online sessions, but also I hope that the recordings and the rendering of the recordings will work. So from my perspective, I suppose there will be at least six sessions similar to this one, and within this week. So today, on Wednesday, on Friday, we are going to do the stuff which is more into some programming, but don't worry about it. I think it's not like so much stuff like some math or math 1 or 101 or things like this, or some computer science classes. Don't worry about it. Definitely, we are going to skim over the surface, and so I'm going to go too much into details, and I will try to to explain the stuff in a more layman terms, just to make all the terms understandable for students of medicine. Okay, so saying this, you know that maybe I told during the biophysics class that I'm also I just general medicine physician, like an oncologist one. So yeah, I will try to talk about it like if I would be only an oncologist. Well, just not considering the fact that I'm also a statistician with a second master degree. Okay, so this week doing more about some handling of data, like in more generic way, like data structure, data types, operations, some handling with if-else condition cycles, warnings, input, output handlers, and so on. User-defined or inbuilt functions, things like this. And I think it's important because you can by this you will see that R is much more powerful than Microsoft Excel, and also much more powerful than some clickable commercial statistical softwares like SPSS and many others. So this is the way. Still, as I told you before, I'll try to handle all the stuff in let's say easy to understand, easy to follow. Let's say level of difficulty. Well, and the next week, from the next Monday to the next Friday, I suppose that we should go more into some statistics or some data analysis. I think the data analysis and data science rather better buzzword than a statistics. It sounds more formal, like academic statistics, you know, some stuff like mathematics and discrete mathematics, combinatorics. So forget on this. Do more about data science, like for example, from more more within the scope of a medical doctor. Like for example, you have the data, or you are, for example, in some field, in some area, you are interested in some area or field of science, biomedical science, or medical science. You are able to collect some data, for example, some patients or whatever, and you would like to, for example, go more into the data, some behavior of the data, detail the data, some associations, some interesting points which could be hidden in the data. And at the very beginning, regardless of if you are a statistician or medical doctor or whatever, but usually, for example, you could have some background in medicine, in the science, in some data science handling and so on. It could be done. It could be, why not? But at the very beginning, before we are going to more deeper into data, in general, you know almost nothing about your data, your individual data you have just collected. And this is the right consideration about, for example, how you can imagine that this is a typical situation which we are going to face it, or something like, for example, if we are going to take part in a student scientific conference, which is a yearly action at this faculty, or for example, if we are willing to study a PhD program after your graduation, general medicine study. It doesn't matter, whatever. Regardless of the situation, in each of them, definitely are going to face this kind of problems. You collect some data, and you are not knowing much about them, and you would like to know more about them, and you would like to, let's say, extract some interesting points, some interesting facts, some interesting associations or relations, whatever. And this is like, as I told you, it's not so much, for example, dependent on the fact if you know, for example, rigid mathematics or rigid statistics, because at this very beginning, even if you are a well-trained statistician or well-trained mathematician, at the beginning, before you are starting to work with the data, you know almost nothing about them. So don't worry about it. Yeah, we are going to do it in like a more interpretable way. Not so much. I'm not going to go not so much into some mathematics. I think at this point, I think that there are some hard formulas in my slides, so don't worry about it. Yeah, it will be rather about understanding the data, yeah? About uncovering of the stories behind the data, something like this. Yeah. Well, so the next week it will be about some exploratory analysis. This is the point that if you know almost nothing about the data, you know, for example, only the way how the data were collected or something like this, or for example, some origins of patients or whatever, but you don't know something relations about it. But you would like to know. Hypothesis testing, it's a classical way. Inference statistics, sometimes called inference statistics. If you have some hypothesis, it could be based on your let's say, experience or some heuristics on some previous literature, whatever. It's important to know some basic approaches, for example, like t-test or variance test and ANOVA and so on. Yeah, this is also, yeah, as I go analysis of variance, ANOVA or ENCOVA, like models like this, linear models, some correlations, also stuff you should know about. I think that some of the stuff could be, for example, in Excel, some clickable software, definitely they could be done there. But I think that almost at the end of this session, you could realize that some of the stuff could be done much more elegant and much more easier way using R than using, for example, Microsoft Excel. So this is one of the outputs of this class. I would like to show you that R language and R environment is somehow, and in some cases, much more appropriate and much more comfortable to use to handle some data. Well, what is important, I would like to go more deeper into some linear regression, linear models, because this is like something like golden standard in biomedical papers and whatever. If you know something about linear regression, about some interpretation, some summaries, how to report linear regressions, because linear regression means that you have some bunch of variables, one or more, which could be somehow correlated, it doesn't matter, yeah. And you have one output, one target response variable. For example, you would like to realize how is, for example, patient blood glycemia, for example, related to gender, age, for example, some condition of, I don't know, some other blood parameters or whatever, yeah, many other parameters. So we can apply this kind of linear or non-linear model, just handle it, and you can get some very interesting and easy to understand outputs from this kind of model, which can describe what are the relations between the predictors, between the exploited variables and the output variable. Well, and what is also interesting, in linear regression, we usually suppose that the output variable, the responsible one, is just a continuous one, yeah, like a human body age or glycemia or whatever. For example, I don't know, some concentrations of some cytokines, whatever, concentration from some drugs in blood, whatever. There's just a range, regardless of its weight, range of continuous values, such that the variable could become any one of the values in this range. But in a kind of different situation is with logistic regression. You, for example, have also a bunch of predictor variables like gender, age, some blood parameters, like these are just one-dimensional, one-dimensional variables like glycemia, I don't know, acid, uric in blood, whatever. And you have one target variable, one output variable, which is non-continuous. It's just, for example, a discrete one, or better say, it's divided into some classes. For example, typical situation for medicine is there's a class like there is a, for example, diagnosis and there is not a diagnosis in one of patients. Yeah. So in other words, if for example patient is positive or negative, for example, regarding some diagnosis. Yeah. Or for example, similar situation. For example, if there is a cancer, there's a tumor, for example, based on some predictors, or there's no tumor, yeah, also pretty unstable situation. So this is very interesting. So it means that you would like to predict not like an individual value for individual patient, for example, how, for example, glycemia or level of insulin resistance, say, of patient is. So it's not like a continuous output variable, but it's one of a few classes, such that each of the patients belongs exactly to one of them. The patient is positive or is negative. For example, nowadays, pretty currently, it's current situation. For example, we would like to decide if a patient is COVID positive or COVID negative based on some, for example, blood markers. Yeah, for example, like this. Also, we are not going to predict continuous output variable, but we are like to predict discontinuous, for example, only a class of a target variable, like positive or negative. Typically, usually there are also only two classes, like for example, positive or negative, or there's a diagnosis, there's no diagnosis, there's a cancer, there's no cancer, and so on. But there could be also more than two classes. We can try to handle it because this is the way I just wrote here some other models which are also expected, and this could handle a little bit more than only two output classes. Well, important thing, which is a GitHub repository. So what's going on this, you should know about it. It's on my GitHub profile, but important thing is that if you are going to go there, there's a repo academic year 2019-2020. I think it's called shortened online version of the course. And in this repo, I'll share both slides, codes, and links to rendered records of these sessions. Well, so for today, for this moment, there's just today's slides, this one here, and this code I just prepared here. Well, so it's available here for you. Well, okay. So this was for the beginning. What is R? Okay, so R is just a programming language. It's called scripting, something called scripting language or interpreted language. The term interpreted means that it was firstly written in some low-level language, for example, like C++, C, or Fortran maybe, and it has to be compiled, and also there's an interpreter which is able to read the let's say code which is written in R syntax. The R syntax is D1, which is let's say easy to learn, easy to write, yeah, easy to understand, easy to read for a human naked eye. But there is an interpreter which is able to read this R syntax, and it translates it into the, for example, something which is understandable for C++ or whatever, and it's run, it's executed using the low-level language like C++. So by saying this, you can realize that there is some additional time within the translation from easy to understand syntax written in R and to the basic low-level syntax, for example, in C, C++. This is additional time, for example, which is, for example, not included when we try to learn C++ itself. Yeah. But on the other hand, okay, on the one hand, there is just the additional time. So the execution time is not so much fast, let's say. But on the other hand, the big positive, big pro of our language is that the syntax which we have to write in our code in, it's easy to learn. It's much more easy to learn R syntax than C syntax for an end user of our language or programming language. So that's a good point of news, good piece of news for us. So yeah, interpret means that yeah, it's executed using in a different language, like behind the scene, behind the console, we are able to see it. But on the other hand, we have used whatever paradigms and whatever or nice and easy to understand syntax. Paradigms means that there are, let's say, different approaches how to write your code, how to think about your code. It's not so important for us, but definitely we are going to use the imperative. Most of the time, we are going to use the imperative paradigm. It means that we are going to write a bunch of code which should be correct both regarding the syntax and the semantics. Yeah, we are going to write it in R syntax. This is the easy one. And we are going to execute it using the interpreter, using the R console. So, like, there is something which should be interpreted, like in imperative for a console. Yeah, I'm going to ask my console to execute a bunch of code. This is pretty imperative paradigm. Sometimes also called written like paradigm. Well, the others, not so much important because like functional paradigm is interesting because it's not so much based on usual architecture of computers, like maybe about Alan Turing's and John von Neumann architecture, which is based on some hardware parts of computer. And by saying this, you are able, for example, to calculate some assembly time, complexities, and estimated times, how, for example, some operations will take, how much time it will take, and so on and so on. But the functional one is based more about something which is called Lambda Calculus. It's not so easy to understand, like, for example, on the other, it's easier to understand, yeah, the John von Neumann Turing architecture of, it's just a classical binary digital architecture of today's computer. So we are not going to go much more into functional paradigm. Forget about it. It's interesting to know about it. We could be able to write a code with the functional paradigm, but I think it's not so much. It's not so much it is for us, like guys at medical faculty. Objective paradigm means that, for example, try to realize that there are some methods which are classes, like, for example, a class of linear modulus methods, class of inference hypothesis test methods, and so on. So bunch of similar methods, yeah, which creates a class of methods, because all of the methods within one class, they share some similar properties, some, for example, similar inputs, similar outputs, similar ways of computation, and so on. And so it's based on some classes, class of inference test, class of linear modulus, class of, for example, plotting functions, and so on and so on. And we would like to use an individual test, for example, a t-test or variance test. This is just a one object, one representative of such a class of inference test. So use by saying this, by applying this paradigm, it's, for example, it's a paradigm pretty usual for example Java. Yeah? If you know about Java, like a Java programming language, you know, the icon with a coffee, yeah, Java. It's pretty based almost only on object paradigm. Because it can employ some relation between the classes and objects, like isomorphism, hereditary, and so on. Also interesting, but not so much important for us. So as I told you, imperative paradigm. RSA usually supposed to be a domain-specific language. It means that at the very beginning, usually all of us, or almost all of us, we just got some data, we got some questions about data, some hypotheses, and we would like to analyze it. But of course, we have realized that Microsoft or some clickable commercial software is not enough to handle our data, for example, from some reason or another. For example, there's, for example, not an appropriate method implemented in a commercial software. It could be, for example, typical situation is that, for example, if we share 2 times 2 exact test is, for example, the only one which is implemented in many commercial softwares like SPS and so. So it's limited on a matrix 2 times 2. Yeah, there are 4 cells in a 2 times 2 continuous table. It's okay, but sometimes it's not enough, because, for example, we have more classes than only 2 and 2 involving 2 variables. So in such a case, you are going to struggling about it, because neither the Microsoft nor many of applicable commercials are able to handle with larger continuous tables than 2 times 2s, for example, by ongoing Fisher exact test. Typical limitation, or some plotting limitation. For example, if you try to do some nice plots in Microsoft Excel, I believe it's possible. I think that Microsoft Excel did a lot of work, and for example, today's versions, one of the last versions of Microsoft are they are really better than the solution before. Yeah, definitely. Nowadays, Microsoft Excel, I think it's applicable. Maybe like it's not like a statistical tool, but still you can get some, let's say, appropriate mean plots. It could be, yeah, but yeah. Still, if you would like to have something very special, for example, like some survival curves, some Kaplan-Meier estimators, yeah, like historicals, or some more dimensional plots, I think that Microsoft and also a majority of commercial software is not going to be able to, handle with specific, or let's say difficult task. We want to put some very detailed things, very detailed relations. Yeah, so that's the problem. So at the very beginning, many of us faced the problem how to handle with some data, how to analyze some data, and then it was just a, let's say, reason for us to start moving out. So saying about the time, firstly, there was just a data, there was some need to analyze the data, and afterwards, we started to learn R. It's very unusual to have it in a positive way. So firstly, there is just like a, for example, feeling like, okay, I would like to learn programming something, and I would just pick R as my language of choice. It's very unusual, because if you are just going to learn programming nowadays, or for example, I don't know, 10 or 20 years ago, a typical language which was like a first one to learn to program in was a Pascal. Maybe you know about it, yeah. its name according to Blaise Pascal, like the scientist, like I think maybe I don't know if medieval or just Blaise Pascal. But I think nowadays, like a typical learning, just learning programming language for, let's say, like the number one language for programming, it's Python. Yeah. But it's not an art. So it's very, very unusual to start learning programming with art. So like like considering it will be as in a positive way. Like firstly, I was bored, and I just had some feelings to that I would like to learn to program in something. I choose I would choose R, and then after some, let's say, time, I first limit some data I would like to analyze in R. So in this direction, it's pretty unlikely. So firstly, there were just firstly in many cases people that were just data and need to analyze them, and based on this, people usually started to learn R. R is also an open source language, open source software, which is very important to say because many software we are going to be equipped, for example, during the study at this faculty, they are available for you only during or throughout your studies at the faculty. Once you are going to graduate, I think that your license is going to expire, and that's a problem. What is a very, very pleasant fact about the R is that it's both free SMB and free as in speech. I'm going to explain it. Free SMB means that it costs absolutely zero. So feel free to download it just for free. Yeah, there's no charge. It costs like $0, absolutely nothing. So feel free to download it. It's pretty it's free of charge, and I think it will be almost free of charge. And the second term, free as in speech, means that the source code of R is open. It means that if you, for example, feel confident enough and you know something about R, you, for example, know something about also C, and you know some of the development of software, feel free to try to, for example, change some source code, to enrich the source code by some new functionalities, new modalities, new procedures, whatever. And it's very likely that if you did a good work, which, for example, can help some other people and can help, for example, like the R language as an entire software, it's very likely that your changes are going to be, for example, joined or just included in the next, for example, publishing or next volume of next version of R. The R is usually updated maybe several times a year, so yeah, it's pretty likely. So both free SMB, it goes zero money, absolutely free of charge. And if you feel confident enough, you can try to, for example, contribute on some open source, change it just to make our better software, even better software. Well, but the first thing that it's a free SMB, it's important because, as I told you, many software are going to use during the study. They are just paid, or you are going to get some license based on the fact that you have student faculty. But after graduation, the licenses are going to expire. For example, Office 365, I think it's limited only exactly on the your study time. Yeah. For example, once you are going to graduate, you are going to once you graduate, I think the license is going to expire after 3 months, something like this. But you can use R for ages, for all your life. Well, at the beginning, how to download install R. If you try to go to this website, like rproject.org, click on this. I'll try to follow it, and there is something like to download R. Yeah, it was just pretty the first hypertext link here. So try to click on it. Here, I get for sure you can use the zero clouds regardless of on a place, wherever on the planet of Earth we are at this moment, or you can just try to find a server which is closer for them to you based on your geographic location. Yeah. And then, for example, I'm just going to use the zero cloud to make things easier. Okay, based on your platform operating system, if you're in Linux or Mac or Windows, you can see that R is split in multi-platforming. So you can choose based on your platform. One, I think that most of you use Mac or Windows. Click on for Windows, and this is like the choice, first choice. Install R for the first time. That's like I think the anticipation of many of you. So click on this. I think that, yeah, you can download it to your desktop and then just follow simply the instructions of the something like installation wizard, or it's called. Yeah, it's pretty easy. I think it takes about 1 to 3 minutes. Yeah, just download it and install it, because it has something like 84 megabytes. So it's not like, I don't know, 7 gigabytes or something like that. So it will be pretty quickly down. Well, so it was about R, and it was like R console. It means this is the thing I told about it before, like R interpreter. Yeah, the tool which is able to understand R syntax and able to execute the code and returns to us the outputs. And what is also, let's say, is also maybe useful for us is RStudio. RStudio is something a bit different than RCore. Okay, I will just call this RCore. Yeah, it's usually called R, but sometimes it could be called like RCore. RCore to just make the thing easy to understand. And this is RStudio. RStudio is a graphical IDE, integrated development environment. It looks like this. So you can see that there are some clicking, I don't know, pop-up windows and some tabs, and what are some many of the roulettes. These are just the tabs with my scripts, and you can see that this is just a part of dedicated to scripts, and this is like a console. So, for example, if I'm going to write something here, which would be in a correct R syntax, this is in a correct R syntax. Let's believe it. Sorry, I just wanted to. Yeah, I just selected a block and pressed Control and Enter, and it was run. It was executed like it was printed this string hello world. So this is the script, and this is the console and output to console. Well, so the RStudio could be also installed for free. If you go to RStudio web pages, I think it should be also very intuitively. Yeah, RStudio Connect. I just have to okay, products, RStudio. Yeah, you understand RStudio. So products and RStudio, and yeah, RStudio desktop. Yeah, I think that no one ever uses RStudio server, because I think that we have no possibilities to have just to share RStudio servers. So RStudio desktop, this is like the tool like I showed to you before. Download RStudio desktop by this open source edition, so no charges, absolutely free. Yeah, there is something like a pro version, but forget about it. I don't know what is desktop pro version. Forget it. Open source edition is pretty enough for us. It's also pretty enough for let's say professional developers. Yeah, so I think forget on this. So this is our choice: open source edition, and download by this. To be downloaded. Also, then you can just it's like the free version. Yeah, we are interested in the free version, because there's like a pro, so don't think about this. Download and so on and so on. And also, it also takes a few minutes. Well, the first thing is just to realize how the workflow is in RStudio. So this was what I showed you. So in case I would like to, for example, open a new script, like file, new file, and R script. And I'm just going to do something which I believe it's intuitive for you. Like I'm going to introduce two variables, x and y. So x is equal to 5, y is equal to 8, and I would like to get summation of these two variables. Yeah, not a big deal, but just for illustrative purposes. So how to work it? Okay, maybe the first thing I should save it. So you can save your script like file, save it encoding, choose for UTF-8. I think that on Macs there will be some like Latin 1 or Latin 2. But if you have a choice of UTF-8 at your Macs, choose a UTF-8. If not, choose for Latin, yeah, Latin 1 or 2. But UTF-8 is the best standard of saving of our scripts. Okay, I'm going to save it. For example, my very first script. Okay, now it's saved, and I would like to, for example, run it. So the first thing I can just select X and Y in block and pressing Ctrl and Enter. You can see in the console that both the lines were executed. X is now, I'm sorry. Okay, one more time. Okay, so X is now equal to 5 and Y is equal to 8. And finally, I would like to get the summation. I can see the summation is 30. Okay. Okay, so this is not the reason we would like to learn how, why you should learn how R, because it's simple calculations. You can do it with some calculator, forget on this, but for illustrative purposes, this is how it works. So in the upper window here, you are supposed to write your R syntax code, and in the window here at the bottom of the screen, it's automatically executed if it was scripted in the correct syntax and correct semantics of R. So one more time, yeah, like in one run, it works. Okay, so this is the let's approach how we are going to work with R, with RStudio especially. So usage of help is also interesting, important, sorry, because at the very beginning or in the beginning parts or the phases of your work with R, I think that you are going sometimes maybe to struggle with some things because everything is new and the things are not so much clear maybe for beginners, for newcomers to R. So there's a very well documented help. There are very well documented help files for all the stuff written and implemented R. You can, for example, yeah. That was just the example. I'm just going back to the original script, yeah, like this one. So the same store here. Select a block, press Ctrl and Enter, and it was executed successfully. So for example, I'm just interested in a print function. How to get the help? The first option is just to type down a help. It's a function itself. A help is just a function, and there's an argument over a function. I'm just writing a print inside. I'm pressing Enter. Of course, I can write it here, yeah, in my script. It will be just maybe a smarter, but honestly, I think that things like searching for helps, it's not like a stuff which should be included in your script, yeah, because the command is so simple that you can write it directly to your console. Help print, and you can see it one more time. Just pop up from the right hand side, and this is just a typical document, typical R documentation, typical help file related to some functionality of R. Print is a function. Here in a parenthesis, there is a name of a package such that the function is implemented with. So it's a base package. It means that base package is one of the, 6 or 7 packages that are automatically initialized at the beginning of every session we are going to start with R. So it means that we are not going to, it's not necessary just to load it like using some library functions or whatever. So it's done automatically. So don't worry about it yet. So important for you is to realize that this is the place where you can find in which package the function is implemented, because it will be interesting for us, for example, in our later phases when you should, for example, get more information about some more advanced functions like LM function for linear models and so on. Print function is pretty easy to answer. Yeah, there's usually an argument which stands for some text character or string, and it's just simply executed like print it out in the console. Print values, this is like what it does usually. Yeah, it prints some values. Description, yeah, because it prints arguments and returns it visibly or invisibly, or does it visibly. Some usage, so some examples, or there are also some arguments which could be modified to, for example, just to adjust your desired output. But I think that many of them are not so interesting. And arguments, these are the arguments. X is just the thing which should be printed. So I think that I can do this, like I can manage it like this to make it also working. Okay, you can see it works. So X is just, but you can see that I can simply omit it if I want to, because usually the main argument, it's usually the first one. It's not necessary to include it itself in the code, because R is very, very user comfortable, very user friendly saying this. So you can see that argument like X is equal to, it's not necessary to have it. It works with it. It's work with it, but it also should work without the first argument. But this is something which I'm going to talk about more about it within the session dedicated to inbuilt and user-defined functions. Yeah, many arguments like justifying, but it's on some aesthetical things, I would say. Details, there are some tricky parts or some details you should know about, for example. So it's I think very clearly written here. References is just the first author who implemented the method, in this case the print function in the base R package. Some similar or some derived functions from print, and very important part of our documentation files are examples. Examples are usually included at the variant of such a file, and you can see, for example, I'm just going to run this. I don't know, maybe this should also work just like this. Yeah, I'm just going to copy by Control-C, controlling in the console. You can see it is something like a triangle of numbers. This is a for cycle for a placeholder I in numbers from 1 to 3. So 1, 2, 3. Print 1 to I. So 1, 1 to 2, 1 to 2 to 3. Yeah, looks like this. So the examples are here. They are relatively simple, but they are here just for you to make a function, or make a function even easier to understand. Well, so it was just a help. Another approach how to find help for your function or an object you'd like to know about is writing question mark just in front of each of the very beginning of the text of the object, like this. There is absolutely the same way. So it doesn't matter if we are going to use the help print or question mark, or sorry, there's a typo. There are two question marks. So these two works absolutely in the same way, and this like two question marks followed by the name of the object you'd like to know about. It works kind of different. You can see that it works. It works maybe unexpectedly long for a long time. So just in a few seconds, we are going to see what an output is. And the output is just a full text searching throughout all the files, all the help files, such that a print function is included in each of the files. So it means, for example, if we have like yeah, the print function. There are many other functions which also uses print, because it's pretty easy to understand, because many functions print their outputs to console too. So they usually use print function. Or there's also one similar which is called cat function. But for example, there's many other functions use print function. Also some plots, some charts are printed to our session using print function. So that's why many of our functions use a print function as one of the function that is included in their code. Well, so this is for important for newcomers to R. Well, data types. We can just start talk about data types. There are several of them you should know about, and I think that some of you maybe already know something about this. Like there's just some real numbers, because they are usually called kind of different in different languages, more low-level languages. Like for example, float numbers or float values, or some single or double values, sometimes called in this way, like float or double or single based on some bit precision. It's not maybe so important for us here in R, and it's a good piece of news, honestly, because here in R we are not supposed to handle some engineering stuff, like, for example, declaration of bit precision. It will be pretty. I think it's not so popular for statistician when they script their analyzing scripts to handle with this type stuff like this. So fortunately, we are not supposed to handle this. So there is only one value for a real numbers, which is called numeric, or real number. It is pretty similar to a real number if you know it from your grammar schools. Real numbers, real numbers like numbers with some decimal, with some decimal digits. So real numbers. So you know that, for example, data which are generated by some real world mechanism, usually they are represented like real numbers. They are called numeric in R. I'm just going to talk about it a bit later. An integer. Integer is just a integer is just a number like 1, 2, 3, 4, and so on, or -1, -2, and so. So these are just the ordinally or cardinality numbers with plus or minus sign. So these are just discrete numbers, and they stand usually for counts of objects. In case that they are just negative, it's just a count considered to be negative. It's not so much feasible, but it's just derived from natural numbers, and these are integers. Logical value, or sometimes called Boolean value, stand for true or false. We are going to talk about it. A string or character string value, it means just a textual string, whatever R is in fact a textual string. But sometimes, for example, if you're going just to write a number in R, it's also written as a string, because, for example, a number like 12, it's going to write down 12, because 1 and 2, these digits are also like a text, But the meaning of the 12, I'm going to look at a class of this. It is a numeric, because the intuitive understand that 1 and 2 together as a 12 number, its meaning is just more as a number, like only a text. But if I like to have it as a text, I can bound it the digits 1 and 2 in quotations, and now it's in fact text class. You can see it's a character. Character stands for a string. Well, okay. And there are some special kind of data types called not available, null, object, and not a number. I'm just going to talk about it a bit later. So a real number value. So a real number, you know it from grammar schools, real number. Like the only difference between real numbers, as we know them from mathematics, and real numbers here in R, they are just called numeric, is that if you try to realize, if you have a computer, digital computer, definitely, since we have a limited capacity, it's pretty easy to realize. Definitely, all the values which, for example, have infinite decimal sequence of decimal digits after the decimal separator, since we have a limited capacity, also this precision, the number of decimal places after decimal must be limited, yeah? And that's the difference. Because, for example, in mathematics, if you have a number like, for example, 1/3, like this, you know that there are 3 up to infinity, let's say. I'm just going to say it, let's say, a simple way. But you can see it in R or general in computer, the number of 3's, since it should be repeated cyclically or periodically, should be ad infinitum, which is not important, which is not essentially possible within computers. So the number of 3's are here limited, regardless of the fact that you know that the number of 3's should be in fact infinite. Well, so this is the difference there, but for an analysis of real data, it's not so much important, because you know that usually if we have some data collected based on some real world mechanism, usually we are interested maybe in first 4 or at maximum 5 digits after this was already maybe yeah, this is important to know. Yeah, I think that's something about it was taught in biophysics by my lecture, but yeah, usually in a real world we are interested only in a few first digits, decimal digits after a decimal separator. So it's not for us so much important that there is a limitation somewhere that we don't know. For example, the digits after the 20th or something like this. Yeah. We know the first 20 digits, and it's more than enough for us in statistics. Well, so how to code real numbers in R? It's more than easy, because, for example, yeah, there's just a sequence of numbers. It's the first one is 5, the second one is minus 13.8, the last one is 4.5578, and this is a this is E notation. It means that this term is multiplied by 10 power to 15. Yeah, I'm going to execute by submitting block and pressing Ctrl Enter. And this is the meaning. Yeah, you can see it's just a, I don't know, it just this term multiplied by E power to 15. Yeah, so it's possible. You know it from Excel. Yeah, I think it in Excel it's written like this. I think the E is in upper cases, but here in R it's in lower cases. So you know it from Microsoft Excel. If I would like to check if a minus 13.8 is in fact a numeric type of data, then it's true. It's numeric. Class of this number is numeric, and what is important to realize, you can see that I have just written a placeholder for infinity, just I and F, which means that it's not a number. But if I'm just going to just go by it into control, it seems to work, because it seems that R knows about this kind of value, because there's no like a red colored error or something like this in infinity. And also let's try some play around with the infinity. If we just try to realize what should be a result of this division, 10 divided by infinity, regardless of the fact if you went through some I don't know, math 101 or some derivations or limits and so on. I think that intuitively it's for example clear it should be equal to 0. Yeah, and yeah, it's really equal to 0. So it seems that in other words, in R there's just implemented of a model of R of real numbers, which includes also plus and minus infinity, because minus infinity also works. Yeah, plus and minus infinity, and also division by 0, like 10 divided by 0 is definitely plus infinity. Minus 10 divided by 0 is minus infinity. Yeah, so yeah, sometimes called like extended model of R languages, R numbers, sorry, R numbers. It's implemented R, and sometimes it's really handy to have to know about it. We can, for example, divide by 0 in R. I'm not sure if, for example, it's possible in Microsoft, but I think there is something like an error of kind division by 0 if you try to divide by 0. But you know, in the real world, if we have something like, I don't know, in considering some real world data, of course, we are not going to have some infinity values there, but we can, for example, have some very large values, and the large values could be almost supposed to be like very like almost like an infinities. So some divisions by them could be considered to be zeros. Yeah? So it's handy, and that's why it's implemented here now. Okay, the next type, data type is an integer. You know, it's just a kind of numbers like a natural one and 0 and natural numbers which are multiplied by -1. Yeah, so it stands for example, if we have a grid, it stands for some separated, isolated steps in a grid, or in a positive on a positive axis, it could stand for counts. Yeah. So, and how to encode them in R? You can see there's something a bit different that it was in the previous case. We just simply wrote down 5 or 13 or whatever, but here there is just a suffix L. Yeah. The suffix is sometimes, I think in English it's not so many times called literal, but I think the etymology of the L is that it was called maybe in some medieval mathematics or something, it was maybe called literal. Yeah, literal. But nowadays it's called suffix, L suffix. It's not important, yeah, but just know about it. That's the way how to encode an integer type into R. So what does it mean? Well, these are integers. And minus 13L, it seems like minus 13, it could be easily a numeric value type. Yeah, why not? But if I'm just going to call a class function on this is an integer, and it's because of the L suffix. If I'm going to remove the L suffix, because it's numeric, so the difference is pretty slight. And I think that within our course, I think that to make the things easier, let's try to code all the numbers as numeric. Yeah? So don't worry about don't be worried about the literal suffix and the integers, because I think that one of the reasons why one should, for example, treat numbers like integers, for example, if you can just save some space or some capacity, or for example, random access memory or something like that. But considering that all of us have sufficient devices, I think it's not our case. Yeah? So it's like for you, if we are going to, for example, handle with some tutorial or whatever, using the L suffix is the way how the integers could be defined there. For example, this is just a class that I'm just going to assign a number 5 to a variable x. Yeah, I'm just going to explain why there's this strange combination of two symbols, but simply it could be simply a equal sign. So x is now equal to 5. We know that it's not a usual 5; it's an integer 5. And for example, I would like to code it rather as a numeric one. So how to do it? This is the way how to do it. You can see that I can pick the x variable, recode it, or sometimes called coerce it to different data type using the function as numeric, and save it back to the, or to make it even easier, save it back to the number of name of the variable. So now x is called x, but supposed to be numeric data type. So x is still a 5, yeah, because both 5 could be both in an integer or a numeric type, but now type is really a numeric. That's the reason that's why we did it. Okay. But as I told you, it's better to handle all the values as a numeric one until you are limited with some random access memory capacity or things like this. Well, integer logical value, important thing, sometimes called Boolean values. If you know something about two values, Aristotelic logic, you know that there's only true or false. Like, I don't know, a predicate could be either a false or a true one. Yeah, so this is pretty good thing. There are only two values, and maybe because you as a medical students, you had or still having a Latin language. Maybe there's something like an idiom code in Latin language. It's called it said tertium non datur. Tertium non datur, maybe you know it from Latin, and it means that in a translation to English, it means that there's no third option given. Yeah, something like this. We have only two options: true or false. Yeah, but in reality, there are much more complex logics than only two values like true or false. So in fact, tertium as datur, or the third option is usually given. Like for example, even in real life, you know that something is true, or it will be true, yeah, true or false, or we don't know if it is true or false. And that's the third option. In fact, yeah, something could be true. We are pretty sure it's true, or we are pretty sure it's not true, it's false, or we are not so much sure if whether it is true or false. And in fact, this is the third option. And for example, you can simply create like the probability or just these kind of tables, you know, with the values of like the conjugation, disjunction, conjunctions, and some applications of tautologies, you know it. So maybe you know it from your schools, yeah. But to make the things easier, in R, the base two values Aristotelic, sometimes Aristotle's, according to Aristotelic, two values logic is implemented based on true and false, and these two values are coded simply by typing true or false. Yeah. No quotations, no simple quotation, no double quotations, only true or false, no quotes. So it's as easy as this. So we're running this line. Yeah, so true is true, false is false. It could also shorten, the true could be also shortened to only on letter T, and false can be also shortened only to a letter F. Yeah, so uppercase T, uppercase F. So if I'm just asking if the true value is logical, yeah, it's logical because it's true. Yeah. True or false is logical. Class of false is logical. So maybe you know difference, you already know to write some code in other different languages. In other different languages, sometimes called Boolean values. Yeah. But in R, it's called logical values. Try to notice that on the line 49, there's just a class true. I'm just asking what is a class of a true, but make a note that try to pay attention to these quotes, double quotes. Yeah, so true is bounded by double quotes. It looks like this. It looks more rather like a string than a value of logical data type, and in fact it is a character. It's a string, so it's not a logical value. It's a since it's bounded. Okay, the double quotes, and it's a character. Yeah, but if I'm just going to remove the double quotes, it becomes logical. But originally going by the double quotes, and since that the character value. Similarly, class G and class F is also logical because of the possible abbreviation of true and false only to T and F letters respectively. Well, a string, important data type, because as I told you before, all the values in fact could be coded like a characters, because as I told you, even a number like 1, 2, 3, since we know it's just a numeric kind of number, yeah, class, yeah, it's numeric, definitely it's a number, and by a naked eye, by a human, by our human naked eye, we can see that it's a number, and we can understand it as a number. We can, for example, consider there were exactly 123 people in such, I don't know, such a room or whatever. So we understand it as, we can consider it as a number, but still I'm able to code it as a character simply by bounding a character. So the way I will code it is that I have a sequence of symbols, whatever numbers or letters, uppercase letters, lowercase letters, some special characters like, I don't know, exclamation sign, question mark, whatever. But if it is bounded by a simple double quotes, it's not important. You can use either simple or double quotes. It's pretty up to you. Then it's a character. So hello, or this alphanumerical kind of string, or for example, empty string, yeah, whatever. So let's try it. You can see all of these. Yes, sorry, this is still in Czech. There should be another hello, but maybe you know it from our Czech classes. Ahoy means simply too high. Yeah, but it's not too high or hello. Czech version of hello, yeah. So character, yeah, class of blah blah, just also simply character. You can see it. This is the case that I bounded the number 1, 2, 3, 123 by double quotes, and by doing this, I've make this sequence be a character, but without the quotes, it's numeric. So similar to this, I'm just asking if an infinite variable, infinite value is numeric, and yeah, it is numeric because we know that just the extension to real numbers like infinity. But if I'm just going to bound it by double quotes, it stops to be numeric because it starts to be character, you know. Okay. Since I told you that all of the sequence of symbols could be in fact coded as a character, for example, in such a case, so I have a variable x of a value 123, just original numeric. Let's see it. I'd like, for example, to change it to character from some reason. Let's suppose I have a reason to do it. For example, the reason could be we have a very long number, of a very huge number of digits, for example, decimal digits. And as I already told you, we have a limited numbers of decimal digits after the decimal separator within architecture of digital computer. So, for example, I don't want, from some reason, I, for example, wouldn't lost precision. So the number of, or any one of the decimal digits after the decimal separator. And in such a case, it's better to code your numbers as characters, because definitely the number of digits which could be stored after the decimal separator is lower than usually 32 or 64. It's some logarithm of this, maybe it's some 70 or something like, I don't know, 30, maybe something like this. Definitely it's lower than 64. For example, I would like to calculate a pi value, for example, and I would like to know exactly 100 of digits after this. So 3 dot, I'm just going to write it now. Yeah, this is a pi value. 3 dot 14, 15, 9, 3, and so on and so on. Yeah, these are my first 6. Just the first 6 digits after decimal separator. But from some reason, I would like to know about first 100 digits after. So from this reason, it's better to
if I have some mechanism how to calculate it, it's better to save my pi as a character, because you can, it's easier to realize that I'm able to save whatever long text as I want to. Since my hard disk is able to save it, it could be many hundreds of pages. So definitely I want to save 100 of first decimal places after decimal, after decimal separated in pi value. Yeah, but it is pretty easy. Yeah, it's pretty easy. But what is not possible is to save the digits as a number. Yeah, you can save it as a character, supposing that each one of the digits is a letter. Actually, it's a letter, basically said. But yeah, so this is the reason why you can sometimes, for example, we like to have it this way, and you can do it by a s character function. So you know that x is a number, 123, but by this, what I'm doing here is that I'm just resaving the x value as character. So I'm just like coercing it to character from digit to, from a number to character string, and saving it back to x. So by running this line, x is still equal to 123, but the only one difference is that there are quotes bounding the value, and the class is intuitively, it's a character. Yeah. Sometimes there could be some applications, but I think not, maybe not in this course. Well, string, yeah, and the special values, NA, null, and NaN. NA is an aberration which stands for not available. Usually, if we have a real world data, for example, it's pretty common situation that some of the values are not known. Yeah. We don't know because from some reason or another they are not included in the data set. For example, I don't know, but they were measured. For example, they were recorded, or for example, if the data file was just rewritten somehow. Some of the values, for example, couldn't be rewritten, or for example, they couldn't be visible, for example, for whatever reason. Yeah, it's pretty common situation in applied data science. So such values are usually coded as not available values. Yeah, not available. NA, which stands for not available, and they are usually called a missing value, or missing values. Yeah, pretty common situation in statistics. Null is a different kind of special value. It's sometimes called a null object. It means that usually we use it for an installation of an empty object. If we have an empty object, but we know, for example, in advance that the object is going to be of some properties, or for example, we know in advance that the object will be definitely a number, yeah, but we don't know what will be just the value of the number. You can save it as a null object, and yeah, that's right. We are going to work it within the, for example, cycles, yeah, because definitely at the beginning we have to define, for example, some sequence or some vector or value which we are going to adjust at within the each iteration of a for cycle. But before the first iteration of the for cycle, we have to initialize it as an empty object, as a blank object of, for example, given properties, and the null object is used for this. Not a number is a special kind of subset of not available values, because sometimes it could happen that, for example, if we have mathematical operations, some arithmetical operations, but they are not maybe legal operations. For example, if I would like to know a logarithm of -1, we know that it's not possible to know it from a grammar school mathematics. Yeah, because but that arguments of logarithm could be only positive values, positive numbers, or similar, for example, arccosinus of, for example, value of 2. Yeah, it's also because arccosinus could be calculated only for numbers within the range of -1 to +1, including inclusively. So, for example, arccosinus of +2 or arccosinus of -17. none of these cases is possible to calculate. So logarithm of -1, yeah, this is the result, not a number, because we don't know what should be a value of this or result, because there is no, like, it's undefined, like just in a mathematical way. So the result is not a number. And also you can see a warning message that in logarithm -1, NaNs were produced, like not the numbers were produced by this procedure. Well, so in fact, if we have another number, it's just a missing value, because we don't know the number, we don't know the value. So not a number, set of not numbers values is a subset of not available values. Yeah. And more examples. If I'm just asking if not a number is not available value, it's true, because all of the not number values are not available values. In opposite case, if I'm asking all not available values are not number values, it's not going to be true, I hope, because there are some, for example, not available values which are not like outputs of an incorrect method or invalid or non-legal mathematical operations. Yeah. For example, if we simply have a data set with some missing values due to, for example, some I don't know, some values which are not properly, which we weren't able to read them properly. Yeah, these numbers are not like outputs of incorrect or invalid or illegal mathematical operations. So there are some not available values which are not numbers, because, for example, they could be like a textual values also. Yeah, and tricky part is this, because 1 divided by 0 is infinite. Yeah, maybe in a grammar school mathematics this will work, and even in Microsoft Excel this will work. Yeah, but here in R it works. So it's not true, it's false, because 1 over 0, so 1 divided by 0 is an infinity, and infinity is a number considering our logic. So it's true that it could be like not a number value. Well, what is also important is assigning of values, because you can see that I'm using usually this kind of signing. But if you like to feel more safe, because this is maybe kind of strange, I'm going to talk about it. But the easiest way how to assign numbers, so values of values to variables, is using a simple equation mark. So this is just a case. X is now equal to 5. The logic is that on the left-hand side of this equation should be the name of the variable. On the right-hand side of the equation, there should be just an individual value which we would like to assign to the given variable. So value is on the right-hand side, variable name, variable label is on the left-hand side of the equation. So this is the logic. It's usual for many the vast majority of all programming languages. What is also important how to assign data in R is that we can replace the equation sign by this maybe strange symbol, which should look like an oriented arrow. Yeah, this could be considered as an arrow which is in a direction to the left hand side there. Yeah, like it's like that I would like to 5 assign to this symbol on the left hand side of the equation to x. So the logic is like this. This is the direction of assigning. So x should be now equal to 5. I'm just going to remove the x from the previous assigning. So now x is not defined. So let's run this, and now we can see that x, in fact, now equal to 5. If I accidentally write something like this, sorry, it means that I would like to, or you know what, I want to write it like this. Okay, like this. this could be read in a way that I would like to replace the number 5 by a value of x, but it's absolutely illegal because you know that I'm not allowed in a pre-programmed language environment just to change the values of a real or integer numbers. So forget on this. Yeah. So the logic is that the value is here on the right hand side, and the label of variable is on the left hand side. So this is illegal. Well, but what is legal and what is maybe the most one of the most very about R is that this also works, because the story behind this formula is that I would like to say or assign 5 to an x variable. And in other words, this is pretty the same logic as was in this line 884, but it was just written in an opposite direction. Yeah. Why not? Why not? It works. Yeah, I'm just going also to remove the x. X now, it doesn't exist now. And let's run this, okay. And x is really equal to 5. Yeah. But I would like to say to you that these formulas is something which we are glad we are going to use them, because it could be really confusing for both sides, for both you, maybe for both me, because this is it's supposed that you are maybe a rather skilled developer in R to be able to, or just to be confident enough using this kind of syntax, let's say. So the best way is just to use equal signs, equal symbols. But the reason why I'm using the kind of orange arrows assigning style is that vast majority of all the tutorials which are published online dedicated to R, some R based, and so these tutorials use this kind of assigning, just using the oriented arrows, which is in fact a symbol for lower than and minus sign. So this is the reason why I'm just using this. Yeah, but yeah, this is the reason. But these two syntaxes are absolutely equivalent. Or finally, you can use an assign function, which is maybe one of the most important things to know about if you are talking about assigning, because by saying this, you can simply use two arguments. The arguments in function are separated by commas. Yeah. And the first argument in assign function is just a label, or just a string, which stands for a label of a variable you would like to assign a value to. And the second argument is an individual value you would like to assign to your variable. So this is absolutely equivalent to x assigned as 5 or x equal to 5. So lastly, let's remove x just to check that x doesn't exist now, and run the last assigning approach, and x exists now and it's equal to 5. Yeah. Also, I can, for example, do like this. Let's, for example, assign a string value, check the value hello to x variable. Now x is equal to hello, or for example, I can do it like, for example, this, yeah, like 2. Now x is equal to 2. Yeah. So it works. So my suggestion is to use this, or the assign function. Well, so this is for the beginning for the types. We are moving to data structures, and we are going to talk more about vectors, operations about it, and some matrices. So the basic, I would say that the basic data structure is a vector. Vector is one-dimensional sequence of values, and all the values in one vector are of the same data type. Yeah. vector is a special kind of vector when instead of you have a defined vector, you also define categories such that each one of the values of such a vector could be equal to. So there's usually only a few categories, and each one of the values within the vector could be equal to one of them. So yeah, this is just a vector. I'm going to talk about it. And metric is yeah, this is the final way final kind of data structure I'm going to talk about today. So vectors. So as I told you, it's a one-dimensional sequence of values, and all the values are of the same data type. So it's important to say. So there is, for example, I don't know, vector of 10 values, and each one of the 10 values are, for example, numeric, or each one of them are logical, yeah, or character, or whatever, or NA, or whatever, yeah. So it's not possible to have a vector that, for example, will be just a vector. You can see that vector could be done this way, using a C. I'm going to talk about it, about the mixing of different data types in one vector a bit later. So it's a one-dimensional sequence of values of the same data type, and it doesn't have a prior column or row orientation. So we are not supposed to think about it like it's a column or row. Forget on this. For example, in contrary to Microsoft Excel, you know that if you have some data in one column or one row, you know exactly if it's a row or if it's a column, because you know it like it's coded in your spreadsheet and in Microsoft Excel, you know. But in R, it doesn't matter, yeah, because in reality, if we have, for example, 10 values, like 10 body heights of 10 patients, in reality, if we are, I don't know, if we are not so much in statistics, it's not important for you to know if it's stored as a column or row. You are interested in the 10 values, and for example, you are interested in mean value, average value of these 10 values. So it's like a tricky part of R. Yeah, it's not important for us to know if it's just a column or row or column. Why? Yeah. So yeah, maybe it's good to know. Yeah. Also, a vector is a tuple. Maybe you know what a tuple means. It means that it's just a sequence which respects an order of its values. So it means that it's really important for us in data science, absolutely in statistics. For us, in what is, for example, the first value, what is the second value, what is the last value, absolutely matters, because, for example, sometimes we know, for example, typically for some time series or for some serial analysis, usually we are interested in the, for example, in first 100 values, because usually we know, or for example, we are interested in the last 100 values from the time series, because we know, for example, the values before the last 100 values, for example, they are old enough such that we are not, for example, we cannot trust them, and these old values are, for example, not so much, for example, for example, so important for us. They are not like, yeah, they could also input some or insert some noise, for example, in our analysis. So yeah, so we are usually interested in, for example, if we are interested in some predictions, absolutely are interested in the for example, current values, in the newest values, absolutely, because the predictions are easily to be made, for example, based on current situation, to predict, for example, what will be just some forex currency ratios based on data old 2 years, for example. We are absolutely going to fail to do this prediction, because such data are just too old for it to do this prediction. And so if order of values is important, and that's why vectors respect order of values, and it's called tuple. In contrary to this, maybe you know this is, you know, what a set is. For example, a set could be, for example, it's just a it's just a bunch of values such that each one of the values is unique. So there is no possibility to have any duplicities in your sets. So each one of those are unique, individual, and usually there is no any respect to their order. But in the vectors, there is it respects order of its values. Well, way to be great using a C function. C is like an aberration or initial of a concatenate verb. This word which stands for concatenate, like join different values in one larger object. It means concatenate. So C as concatenate. So let's take a look at examples. So C and round brackets without any values. It's also a vector, yeah, but it's an empty vector. If I'm just interested in getting the length of such a vector, you can see the length of it's just a 0 because there is no item in such a vector. So yeah, it's length is 0. Vector of numbers 3, 1, and 2. Let's take a look that the values are separated by commas. They are bounded by round brackets, round brackets, and initialized by a C function. So this is the appropriate how to create a vector of values. So C, and in brackets there are just the values 3, 1, and 2. Yeah, this is just the vector. I'm going to take a look more in this class. Yeah, the output is numeric. Okay. Well, similarly, there is a vector of 2 letters, A and D. So you can also see that there are just only numbers, there are only letters, and so on. And this is just the way how we can extend a pre-existing vector 3, 1, 2 by a new number, last value. You can just simply use the formula for creating the previous vector and repeat one more time and add the last value here. So the reason or just a result of this is a vector of 4 numbers, 3, 1, 2, and 4. And this is just the way how to do it, maybe in more easy way. But this suppose that you know the values from the previous value. For example, this could be, for example, replaced by an X variable, for example, or something like this. Okay, I told you that all of the values in one vector should be of the same data type. So let's try to do something like this. So 2, 8, and 4. Okay, X is definitely a vector of 3 numbers, and the type of the numbers they are just numeric ones. Well, you know what? You can try to do this kind of workaround. So you can see that I would like to have a vector with 3 values. First 2 are usually it should be numeric, or I can simply add okay, put like this. Yeah, I'm gonna L suffix to make this the first 2 integer. Let's give an example 8.7, and the last value is character, yeah, because it's bounded by double quotes. So let's run this command. It's run, and you can see what does that mean. Let's take a look at this. Class of all the values in such a vector of X are a class is character. It means that the first and the second value, the first should be integer, because you know that 2 with suffix L itself, if I'm just going to call it this way, it's an integer. Similarly, you know that 8.7 itself, sorry, it's numeric, yeah. So the classes are different, the data types are different, yeah, but they were coerced automatically to character. And also you can see that the first 2 values are like automatically bounded by double quotes, like respecting the fact that they were automatically coerced to characters. And yeah, so this is the appropriate behavior of R in case that you would like to mix a different data type in one vector. Yeah. So take a look at this. It's important. In each case that there are different data types in one vector, they are automatically coerced to such a data type. Let's say trying to not hurt the data. It means that we would like not to, for example, lose any precision or any information. So saying this, they are usually coerced to be character, because you know that everything could be coerced to character. In fact, everything which is written could be a text in simple words. So yeah, this is the way. For example, in maybe in a different situation, this is also important. You can see that just integer, numeric, integer. Let's take a look what is the result of this. Oh, sorry, this typo. Numeric, because it's going not to lose any information in case that the first and the last number, which we coded as integer, if they are coerced automatically to be numeric, yeah, why not? Integers could be coded as numeric values. Why not? We are not going to lose any information by this. So yeah, this is the like automatic behavior of R, but it's done in a clever way. So in such a way that we are not going to lose any information if possible. Well, yeah, what is also important, I'm just going to do some basic manipulations with vectors. Sorry, this is like that I have x vector of values 3, 1, and 2. I like to have now length of distance 3, yes, yeah. Y, you can see that y is now a vector of a value 1, but it's a simply a one value. So y could be considered to be both a value or a scalar value. Yeah. Simply one value or also a vector of one value. Doesn't matter. Yeah. For R, it's pretty the same. Yeah, exactly on a z. Line of z. Z is coded as a vector for value 2. Yeah, but if I'm going to run it, that is simply a number 2. Yeah, why not? It's numeric. Yeah, why not? So it was coded as a vector, but since we know it is only one value, it's like considered to be this value. W is a vector of 2 values. Yeah, numeric. And here you can see how to extend a vector by a new vector, a new value. I'm just going to take x, concatenate the x vector with y vector. We know that y is only one value, but it doesn't matter. And take this and assign it back to x. So the x is extended by y vector and assigned back to x. So by running this, x is 3 numbers letter, y is 1 number. So running this command, I'm just expecting to get a vector of length 4. This is yes, sorry, the class is okay, but x is really in fact a vector of length 3, 1, 2, which is the original x vector, extended by a value of y, which is 1. Similarly, I'm just going to extend a w vector by a vector of z and assign back to w. You can see it works 5, 7, 2, 5, 7, 2. Well, maybe the last thing about this is about realizing that if we have we know that C is a function which could be used for concatenating of numbers in one vector. But at the line 119, I'm just assigning this vector to a variable C. Okay, in some lower languages, this could be illegal because I'm just using a reference name for a function C as my variable name, my variable label, and assigning something which is a product of this kind of function, concatenate function, back to a C. But in R it works. Yeah. I can see that C is an existing vector, and still I can, for example, use C as a concatenating function because I'm still possible to concatenate vectors. So it's important to know that it's really user friendly. That in one other section I can have both function of some names, yeah, and also objects of the same names as a function. So in other words, the names, for example, of functions are just the procedures behind the functions which are named as the same way as, for example, some objects, some variables. If I'm going to rewrite a predefined predefined inbuilt function, in this case it was just C. If I'm going to say something different in a C, I'm not going to rewrite the original function C. And it's important to know because it's very user friendly, because it means that we as end users of R, we are not supposed to treat any, I don't know, name conflicts or some, like, for example, some very strict name name strategy or something like that. You know, it's not so important. It's not so important for us. So we are not supposed to bother with this stuff. And it's very friendly, user friendly, because yeah, try to realize that, for example, if for example this kind of rewritten would be possible in R, it would require from us as end users to know all names of all inbuilt functions and other inbuilt objects, to have a list of all the names and to use only names different from this list for our own objects. And this would be really user friendly, and it would be really tough. I don't say that maybe sometimes this is probably important for some other languages. Yeah, it is more lower languages to have some well treated name strategy, how to name your own objects and procedures. But fortunately in R it's not a big deal. Yeah, we are not supposed to think about it, yeah, because it works automatically. Yeah. Okay, there is just an exception. I'm just going to mention it, like it's not in slides, but there's something which is called global assigning, to using a global constant. And by using global constant, you can rewrite inbuilt procedures or inbuilt functions there. But definitely we aren't going to use any global constant, global assigning in this course. And also, it's not even recommended to use it even for more skilled developers to use any global assigning in R, because there is something which is called flexible scoping in R, which is let's say inbuilt principles and statistics, how to handle with how to handle with the names in appropriate way, such that they are not rewritten, for example, by a user if he or she doesn't know before that the name is already taken by a different inbuilt object. Yeah, so this is important. So it's good piece of news for us that we are not supposed to just to struggle with this much. Yeah. Okay, so vector of characters also important. The vector of characters could be used as names for other vectors which are only vectors of values. You see it here. If I have, for example, vector of y of values 3, 1, and 2, sorry, vector x 3, 1, and 2, and vector y of 3 letters a, b, and c. For example, from some reason or another, I would like to have the names for my items, my slots in the vector x named by a, b, and c. And you can do it this way. First, let's take a look at this an output of this command, like names of x. There are no names of x because we know that the vector x is just there are just 3 numbers in the vector 3, 1, and 2. So names of x is there are no names of vector x, so this is just a null object. But I would like to have these names, so let's assign vector y, which stands for these 3 values, to names x. So let's run this command. And now if I'm just going to take a look at vector x, I can see that the values 3, 1, and 2 are really named by a, b, and c. From some reason, for example, I'm not so much satisfied by these names, so I can unname them. So by running this, there is a name. So I'm just going to assign it. Now X is without the names. Yeah. I can also use the set names function to which use two arguments. The first one is what should be named by something, and why is the vector of the name. So X is a vector, initially a vector, which is initially not with any names, and Y is the vector which could be used as names. You can see it. It also works well. Very important thing is a subvector indexing or addressing. These three terms usually means a very similar thing, and sometimes we realize that if we have a long vector, I was already talked about it. For example, if we like to have some predictions, some current predictions, we are interested mainly in the current or just up-to-date values, not so much in the older values. So for example, we would like to take a subvector, so it's a part of our vector, so it is a shorter vector, which is a part of the original one, and it's called subvector, and sometimes it's also called indexing. Maybe it's sometimes you can try to understand this in similar way, like the addressing from Microsoft Excel. There was just a dollar sign notation, I guess, using to make some notation or some fixing of some values in cells when you try to think about some formulas in Excel. So this is pretty similar way of thinking, but I think it's easier in R than in Excel. So if we know that vector is a one-dimensional object, the only thing which we are interested in is, if, for example, is the index where the value of our interest is placed or stored within the vector. It means that, for example, if we know how the vector looks like, or even if we don't know how the vector looks like, we can try to pick up, for example, the first value or the second value, or for example, the last three values, or maybe the last one, the very last value, and things like that. So things which we should have about the R indexing is that R starts indexing by 1, not by 0, which means that index of the first value in a vector is 1, index of the second value in a vector is 2, and so on. Okay. If we have this vector of X, there are 4 values, so index of the last value minus 3 is equal to 4, because it's just the fourth value. And also, the second thing we should know about is that we should use like the rectangle brackets, simple brackets, not the round brackets, but the this brackets, the rectangle brackets. So maybe you realize that we use the round brackets for the concatenating of a vector, but by indexing, by grabbing an individual value from the vector, we have to use brackets. Yeah. So let's take a little example. So X, so vector 4, 2, 6, minus 3, and I'm interested about knowing the first value of the vector X. So syntax is number of the vector, now brackets, not the round one, but the rectangle one, and the index of the value I'm interested in. So X, the first value of with the first index. So 4 is the first value. You know that I told you that vector is a tuple, so order of values in a vector. That doesn't matter. Yeah. So this means that I'm interested in 1, 2, 2. So I'm interested in values from 1 to 2. So with index 1 and 2. This column could be read as 2, yeah, from 1 to 2. There could be, so from 1 to 2, these are the values 4 and 2. If I would be interested in values from 1 to 3, these will be 4, 2, and 6. Given to 1 to 4, these are the whole vector, entire vector of x. Let's try to return the fifth value of the vector. You can see there is not available because you can realize that the length of the vector is only 4. There are only 4 values. So the fifth value is not included in the vector. We don't know what is the value of the value. Maybe there sometime there will be just some values added, or maybe. But at this point, there is no like the fifth value, and then so the value is not available because we don't know the value. There is no value not available. So what does it mean? It's not going to output you an error, for example, which will just stop all your computations. If you, for example, from some reason, will try to address non-existing values with, for example, some index out of the length of Objectors, yeah. But it only returns not existing, like not available values, missing values. So it's also user-friendly because by this, for example, fact, your procedure could be run to its end with some other results, but not be maliciously stopped. For example, harmful stop by this kind of well, it's not an error, yeah, because for example, from something we don't know, for example, if there is, for example, some value from some stream data, yeah, we just have a real-time on the fly download data, you know, some stream data like, you know, some it's called, for example, some intra-minutes swing, I don't know, forex, you know, this kind of business like forex, and so the data are generated, for example, on a for example second basis. Yeah, each second there's a new value. So, for example, we don't know if the computers are really fast. If there's, for example, if the value was recorded or not. So we cannot know in advance if, for example, the kth value is missing or not. This is like the way how we can, for example, try to address the last value of the vector, because there's no like a placeholder like, for example, -1 in Python or end placeholder in MATLAB. We have to do it this way. Length of x is a length of the vector, regardless of the fact that I know it before. Yeah? I can see the vector x, so I can say that, okay, the length of this vector is 4. I can see it. I can say it this way, of course. But supposing that I know the vector x in advance, this is the safe way how to get the value of vector I'm not aware of before. So length is x. So if I'm going to run this, then I'm just thinking outputting of the last value, or the fourth value, a value with the index 4 of the vector x. It's -3, so that it works. The next line is how to, for example, pick the first, the third, and the last value, the fourth value of the vector. You can see that it's done using this vector by combination of the values with index 1, 3, and 4. So by running this, I really got the values 4, 6, and -3. Yeah, so it works. It really corresponds to the indices. The next line is that I would like to have values from the length of x. So this is the last value, from the last value to the first value, because you already know, I'm sorry, from the last value to the first value. So I know that the colon stands for like for the word to, from to. So from the last to first. In other words, I'm just asking to get from an inverted sequence of the values in my vector x. And in fact, I got it. Yeah, you can see -3 was the last one of the original vector, but now it's the first one. 6 is also inverted, 2 is inverted, and 4 is now the last one, but it was the first one value of the original vector x. So this is the way how I can get the inverted order of all the values. It could be done in more simple way by calling a ref function, which means a reverse order of the reverse sorting of the values in a vector X. And yeah, pretty the same result. I think that this function is more optimized to do the stuff maybe quicker. But if we have only 4 values, there's no difference in executing time. Yeah. Well, yeah, still the same vector. Yeah, it's still the same. Yeah, it's 2 times. It's code by 2 times on the way. So okay. Well, so it was for index nursing or making subvectors from a given vector. Logical vectors, also interesting. I like to point out and display that this stuff seems to be maybe not so much interesting, but believe me that if you are going to handle some real data, you have to know this kind of stuff like on a really good basis, because I would say that if we are, for example, would like to, if for example, analysis based on making some linear model, then believe me, 95% of all the time we are handling the data is some processing, pre-processing, post-processing of data. So some manipulation of the vectors with the tables of the data. Methods are more to tables. Data frames is the stuff we have to start with in the next session. But yeah, so the vast majority of all the time we are doing the data science or data analysis, you are doing this stuff. Yeah, we are thinking about, okay, how is the number of dimensions of this object? Okay, can I sort it or can I revert it? For example, okay, I'm just saying in the first 10 values, for example, things like this. Yeah, and the final step is to applying a linear model, which is one function. It's a one-liner, one function, which usually does the nice stuff, yeah, nice and very effective stuff, yeah, just the fruitful stuff, yeah. But unfortunately, before you are able to apply this kind of function or this kind of stuff, kind of functionalities on your data, you have to go through long hours of processing, which is more based on this number crunching and data structure, data tables crunching, and so on. Unfortunately, that's a real life we live in. Yeah. Okay, so so let's continue. This is how we have to do. Well, logical vectors. Logical vectors are usually they are important, and they are interesting in the fact that if we have just a vector, two vectors, for example, one original vector x with numbers 3, 1, 2, and 5, and a similar vector of the same length with values only true or false, which is a Boolean or logical vector, you can use the vector y as indexing one for the original vector x. So how it works? Let's take a look at the example here. So vector y is simply vector of true or false values, true, false, true. The vector x is a vector of 4 numeric data types or data values, 3, 1, 2, and 5. And I would like to get, for example, a kind of subvector from vector x based on indexing done or indicated by a vector y. So it means that it could be pretty done by this x, and in a brackets, rectangle brackets, you can bound by the brackets vector y. It means that I would like to have first value because it's true here. The second value is true here. I'm not interested in the third value because it's a false here, but I'm interested in the last value, the fourth value, because it's true here. So first, the second, and the last are the values which I'm interested in, but the third value, from some reason, is the one I'm not interested in, and that's the point. Yes, and you can see it. R returned for me 3, 1, and 5. 3, 1, and 5, and really it pretty respects the logical vector used as an indexing vector for my command. Yeah, it could be also done this like if I'm just interested, for example, in the second and the last value, I can use it this way. So the second is 1, the last is 5. Really, 1 and 5. So it could be done in this very elegant way. What is also very elegant is something which is called recycling. And let's take a look at this vector z, which is a vector of 5 uppercases letters like R, G, E, F, I. And from some reason, I'm interested only in values with even indices. Sorry, with odd indices. It seems with odd indices. Yeah, with odd indices. In this case, with odd indices. It means, yeah, that I'm interested in the first, the third, and the last value. So how to do it? Okay, you can see that I'm also going to use a logical vector as an indexing one. But let's take a look at this case because you can see that the length of this vector is only 2, while the length of my original vector z is 5. So it seems that there is just like something like a discrepancy between the lengths, and it seems that it should not work here. But there is something which is automatically done by R. It's called recycling. It's done. It's some kind of procedure that the index vector is multiplied by an appropriate factor such that it's mapped throughout the whole vector, entire vector of z. So if the length of the vector z is 5 and the length of the this index vector is only 2, the 2 multiplied by 2.5 is equal to 5. So this vectors is multiplied by 2.5. It means that it's true, false, true, false, true. Yeah, this is the multiplication of 2.5, and it's pretty the way we like to have it, because we like to have true, false, this one not, true, false, this one, yeah, this one not, true, true, false, true, false. So true, false, true, false, and true. Yeah, this is the recycling. So don't worry about the different lengths of your original vector and your indexing vector. R is going to do the stuff instead of you. Yeah, that's really the powerful birth tool. So let's run it. You can see the result. Really, R, E, and I. So all the values with only odd indices. So the first, third, and last value. Well, so this color recycling is, for example, it could be, for example, if you have a very long vector, for example, thousands of values, and you are just only in, for example, every second value, with values with even indices. Yeah, typical, for example, typical task. For example, if you would like to have, it's sometimes done because, for example, if there are many values, I would like to split the values of one vector into 2 samples. Sometimes called so half splitting or something like this, or 1-2 splitting. Sometimes we call this that we have to have kind of random splitting. Yeah, sometimes just split on the even and odd values or something like that, or values even or odd indices. So this is the way how it could be done very quickly. Okay, I'm going to do stuff like this is like not so much into today, but I'm going to now access a vector of 1000 values. I'm just wondering how it's so how or why it takes so much time. Yeah, access a vector of 1000. I have on that. The values with even indexes, so you can see it. I have a very like this is a minus 1.3, and yeah, it should be the second one. Yeah, and so on. So it's the yeah, meaning it where you don't want to do it manually or in so it's, but this is the way how I can get the all the values with odd and even indexes by this or by this. These stands for the indices. Odd indices. This stands for example, indices, or I can also get this. Yeah, for example, every second value of in every group of 4 consecutive values. It could be something like this. It also should work. So it's 1/3 or 1/4 of all the values. Yeah. Well, what is the next step? So I was going to finish vectors. I think that we can do the operations medicine in the next session, just to make this video more, easy to understand, not to make it so much long. Okay, logical letters. This is stuff. Vectors. Very, very interesting thing. You know that we know about the vectors of textual values, of course, character values. Yeah, why not? For example, if I'm here, this is absolutely the value or vector of values following the character data type. Yeah, why not? But from some reason, for example, I could be interested in a different kind of vector, which also takes into account the fact that I would like to have some information about all the categories, all the possible values within the vector, and to manage them as categories such that I can see what are the possible values, so each one of the values in the vector could be equal to. So I'm going to save this. Let me run this code, and if x is now not this kind of vector like this, but I'm going to call x, it's still the male, female, male, male, but the first difference is that you can see that double quotes disappeared here. That's the fact that I'm using a vector instead of a basic vector. And the next line is here that it says to us that there are only 2 possible categories, female and male. And that's the true here, because we know that the value of male is 3 times in the original vector and female is only 1 time in the original vector. So yeah, this is how is the vector x now called as considered as a vector. You can see structure x, it's a vector within 2 levels, female and male. Since the female is the first value, all the ones in this representation stands for the first value, first category, first level. So only the second value stands for female. In fact, it's here. And 2 assign a letter, just a digit 2 stands for the second value in our levels, and it's just the male value. So the first one, the third one, the fourth one. Well, the order of the categories or the levels within the category set is done. The order is done by alphabetically by their initials. But for example, from some reason, I would like to have male as the first one. From some reason, let's say. In such a case, I have to rerun this command with an extra argument, which is called levels. And I'm going to code the levels manually within the order I would like to have, because you know that vectors are tuples, so order of its value does matter. And yeah, male is the first one, female is the second one. So it's a different case than was in this case. So vector x as a vector, yeah. And now x seems like this, still male, female, male, but you can see that the order of the levels is different. First is male, then the female, but before it was like female and male. Now it's male and female. And what is I think amazing about the vector is that I can get easily a contingency of pivot table by this. You can see the male value is 3 times in our vector, female is only once in the vector. Maybe if you went through our informatics in the first year, maybe you remember that there was just a task like, I don't know, many of the values. I think that it was just of some blood groups based on AB RHA system, something like this, and you have to count up, for example, occurrences of each possible each combinations, and it was done something like countif or something like this. So it was you have to create a new sheet in your worksheet and some stuff like this. So it was based on many clicks, many thinking about using some functions like countif and so on. I know defining your defining of your categories, something like that. It was also dependent on the fact that if you just accidentally made an error or typo in your category name, then your counting up of the occurrences it was crippled. It was a zero automatically and so on, stuff like this. So it was really not so much intuitive. But in R, you can see that it's we done pretty easily by only this simple command. Let's have a vector and use or apply a function table on it, and you can see this kind of output. Yeah. So this is like an example only for values, but for example, with another vector of hundreds of values, this could be very, very handy. Let's say that you are going to use it in Excel. If we have, for example, I don't know, 100 of thousands of observations. By the time that we are going to expand your calculations towards the end or bottom of your table, since it will be done automatically by the clicking on the cross or the white cross, something like this. But still, it takes some time. But in this manner, in the R fashion, it could be done very, very quickly and in a smart way. Well, so that was the factors. Operations is really pretty easy. It's easy, yeah. You know, it's summation like counting up by plus operator 2 plus 3. Yeah, subtraction by minus operator 2 minus 3. Multiplication by asterisk operation 2 multiplied by 3. Division by forward slash. Also, maybe one difference or one thing which would be so much clear at the beginning is that a forward slash is used for division, yeah, not like a colon, for example, how it is sometimes used for them in calculators, like in hand calculators, because you know that colon stands to the word to or till, and as an example, 1, 2, 10 is like the sequence of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. So colon stands for 2, from something to, so from 1 to 10, and these are the numbers from 1 to 10. Well, integer numbers. So for division, forward slash rather than colon sign. Exponentiation could be done by a head sign or by 2 asterisks consecutive. So 2 powered by 3 equal to 8, yeah, or 2 asterisks, 2 stars, yeah, 2 asterisk, 2 powered to 3. These are equivalents. Modulo, it's a kind of special operation. If you realize that you have 2 integers, you would like to have, for example, divide 7 by 3, but in modulo fashion, it means that we are interested in a remainder. If we firstly done an integer division, it means that how many times I can, how many times it could be 3 be included within 7 without any non-integer number, yeah, like how many times I can, okay, how many times you can include this number 3 in 7, yeah. So 3 plus 3 is 6, so 2 times, yeah. But the remainder is the rest, so we still have 1 up to 7, so the modulo is equal to 1 because this is a remainder. Yeah, 7 modulo 3 is 1 because it's just the remainder after the integer division. So integer division is that I am interested in not in a division or product of division, but I am interested like only on integer division. It's like this: percent sign forward slash percent sign. So if I'm going to run it, oh, sorry. 2 times, because if it will be 3 times 3 multiplied by 3 is 9, and it's larger than 7. So integer division 7 integerally divided by 3 is 2, and the modulo is 1. Yeah. So sometimes these operations are maybe handy. For example, we can do a simple division 7 divided by 3. But if I'm going to call a floor function, it's equivalent to modulo division. Sorry, no modulo, integer division 2. Yeah, like this. Yeah. So these are logic operations, pretty simple. Logical operations also, if you definitely all of us are just like internet generation, so we know how are the rules for browsing for some specific term using a browser. So and or just logic, you know, still a Boolean logic. So and operator, which is in our could be done by an and sign, or operator, which could be done by a pipeline. Yeah. So yeah. Okay, some examples. Well, some examples. So this operation is executed pairwisely, following the length of the vector throughout the whole vector. So false and false is definitely false. False and true is also false, because you have to have both values as true to get the result true. So false and true is false. True and false is also false. And the last case, true and true tends to be true. Well, in OR fashion, in using the OR operator, it's enough to have only one of the values to have to be true to get the result true. So false and false is false. Sorry, I didn't run it. So sorry, it's round. Okay, false and false is false. False and true is true. True and false is true, and true and true is definitely true. Well, explanation sign is used for a negative and for not operating. Yeah, like to taking a positive value. So opposite value to 2 is false. It works. 2 is not larger than 3, so it's false. But if I'm going to take an opposite value for it, it's true. Well, all and any function also important. Well, yeah. All functions use that you have a vector of some, let's say, claims or some like predicates, let's say, yeah, some predicates. The all function returns true if and only if all the values of the original vector are true. So in this case, you can see that this is true, 3 is larger than true. Modulo 7, modulo 3 is 1, it's true, but 1 is not equal to 0. So this is definitely false because of the last predicate. In the next case, 3 is larger, this is also true, and 1 is larger than or equal to 0. So this should be true because all of the 3 predicates are true. Any is a function, logical function, which works in a similar manner like a all function, but it's enough to have only one of the predicates true to return true value. So 3 is not lower than 2, less than 2. This is also not true, and this is also not true. This one is not true, definitely. This is false, but in the next case, yeah, this is true. Yeah, this is true because 7 modulo 3 is equal to 1, so this holds, and yeah, so it's true because this, while the first and the last one is not true, it's false, but the second predicate is true in this vector. So as a result of any operation, it's So it returns a true. Well, in comparison, I think, yeah, definitely we can do it. Can do it in several minutes. Okay, operation of comparison, or comparison. So very quickly, 2 is not okay. The difference is that you know that I'm going to remove variable x, You know that this notation x is equal to 5 means that x is from now equal to a number 5, a numeric data type. But if I'm going to use double equal signs, I'm not going to do any signing, but I'm just asking if the left-hand side value and the right-hand side value in such a formula are equal. Yeah. In such a case, it's definitely not true, so it's false because 2 is not equal to 3. Yeah, it's pretty clear. If I know that x is equal to 5 by accidentally typing, for example, this, I would rewrite the x variable to have a value of 4 from now. But for example, this would work and R will execute it. But if I'm going to do this, I'm just asking R to say to me if x variable is equal to 4. Yeah, and it's false because I know that x is equal to 5. So double check if you are handling with assigning or with some comparison, that the only difference is that you have to use 2 equal signs for comparison and 1 equal sign for assigning. So believe me that this is one of the very common reason for many mistakes in codes, which could be otherwise very of a very high quality, but sometimes even a skilled developer could forget to include the second equal sign, and it absolutely changes the logic of the code here. Instead of comparison, you are doing assigning. So instead of only comparison, which is only asking if something is equal to some other thing, you are changing the values, yeah, because you are assigning somewhere. So this is really it's going to be really a problem, and it's also hard to debug it. Yeah, believe me, it's a reason very common reason to many mistakenly run codes. Well, so double quotes for comparison. Sorry, double equal signs for comparison. 1 equal sign for assigning. The function all equal is doing the thing that it's pairwisely comparing first values, second values, and so on within the 2 vectors of the same length. And you can see that there is also an argument which is called tolerance. The first, you can see that the first values are the same, the second values are almost the same, but the difference is 10 power to minus 13. So this is lower than the tolerance. So I think that these 2 vectors should be equal to that all of the values are equal. So it's true. All of those are all of them are equal. Well, but if I'm going to manage, for example, this, like I would like to have a bit lower tolerance, so need to be a bit more stricter. Yeah. Now you can see that there is a large difference, yeah, because 10 power to minus 13 is definitely larger, 10 times larger than the tolerance 10 power to minus 14. So yeah, this is the thing. So the output is that there is just a relative difference which is not equal to 0. So they are not all equal. Maybe, yeah, we are asking why there is 5 multiplied by 10 power to minus, but it's a minor difference. First values are easily the same. The second values were different by 10 by 10 power to minus 13. So this is just the half of this, because 0 plus this difference divided by 2 is arithmetic mean. Yeah. Identical, it works easier manner, because it looks at the first values and the second values and pairwisely compares the values of the same indices. So the first are equivalent, the second are not equivalent, because you can see that there is also a difference. This is a very, very low difference, but still a difference. So identical will return false, because it returns false. Okay, it returns true only if and only if both values are absolutely the same, absolutely equivalent. But there's a difference. Yeah, it could be. I think this is the difference. For example, if I'm going to even closer to 0, yeah, beware of this. I think we are just under the possible tolerance of a digital computer. So maybe this much, maybe around 20. I think it will be also much. Yeah. Or this maybe. Yeah. So this works. Yeah, but for very, very low difference, these two values, 2 and 2 plus, this numerical plus, they are not distinguished. The computer is not able to distinguish between them. Okay, 2 is lower than 3, definitely. These are the comparison using kind of is less than or equal to it. Less than or equal to, greater than or equal to. Yeah. Let's take a look at the syntax. The first sign is the less or greater than, followed by an equal to sign. Well, 2 is lower than 3. It holds definitely. Maybe this is important. This is interesting. Is it even feasible to compare letter B and letter A? I would say yes, because if there is let's say a meaningful, comparison or some sorted list, sorted tuple, which okay, seems that there are some technical errors, but I still hope that I'll be able to do the rendering of the record, because it will be very, very for pleasure if we will just had this session. Well, you know what? Okay, sharing, but there was like, yeah, there was like a message that the Zoom was quite unexpectedly or something like this. So I still believe it works. I'm not sure, but I hope so. So last, okay, I'm still sharing my screen. Okay, so let's believe it will work. I'm not sure. It seems that this will run over the next computer, but sorry, next. Let's see. Okay, well, let's continue. Well, I will start a session, but it doesn't matter. Okay, if there is still something like a tuple or some ordered list like alphabet, you can see that it seems that lowercase letter B and A are not visible to be compared, but in fact they could be compared, because if we try to realize that there is an alphabet of English letters, lowercase English letters, definitely an index of A is 1 and index of B is 2. So indices are the values which are compared, in fact, in this case. So 2 is not lower than or equal to 1, so this is false. Similarly, false is not greater than or equal to 2, because we know that in Boolean algebra, true is equal to 1, equal to 0. So 0 is not greater or equal to 1, so it's also false. Comparison not equal, 2 is not equal to 3, definitely. 2 is not equal to false. Both stands, both holds to be true. Well, I'd like to shut down the R studio, which is going to. Okay, so that's true. Comparison of type is in something if one element is in a vector. In case that we have a vector of values 2 and 6 in a vector of numbers 1 to 5, then for the first value, 2 is definitely a vector of 1 to 5 because these are numbers like 1, 2, 3, 4, 5. 2 is in this vector, so true. And for the 6, the output value is false because 6 is not in this vector. Similarly, I'm just going to run my RStudio one more time. I'm not sure if I have to risk it. Letters is a vector of 26 uppercase letters of English alphabet. So lowercase k is not there, so that's why it's false. Uppercase J is not in lowercases letters English alphabet, also false. May is in what? Oh, sorry. Okay, we have to believe that it will work. My name is just a vector of aberrations. Sorry, not aberration. Yeah, it's just a vector of names of months through the year. And May is definitely there, so that's why it's true. And tricky case is the last one. Alphabet is a word, and definitely lowercase a is here and here in the word, but this is like a comparison of vectors. So this is in fact a vector of one item, which is equal to alphabet, text value, character of alphabet. And a is not equal to this word here. A is a word itself, and it's not equal to a word alphabet. So since a letter A is 2 times included in the word alphabet, it's not equal. So as a result is that this comparison is false because A is not in a vector such as this vector includes only one word and the word is alphabet. Isabel and is referred to is in operation, so it's not important for us to know about it. The last thing is that there are many of mathematical functions, statistical functions within the R, which are inbuilt and prepared for you to be instantly used. If you like to have more information about them or some details about them, try to search for them using the help files. So either you can, for example, copy this name like apps and use it as an argument for a help function, or simply type down question mark in console followed by the apps text. So absolute values, signal, which is +1 for positive values, -1 for negative, and 0 for 0. Some psychometric functions, and so on and so on. These are other mathematical functions like exponent, logarithm, and so on, maximum, minimum, products, summation of numbers, cumulative maximum, cumulative minimum, cumulative product, cumulative summation, pairwise maximum. If we have 2 vectors of same size, values of inappropriate indices, whatever are pairwisely compared, and makes the larger of D1, which is larger within this pair of values, is returned. So as a return of this function is a vector of the same size as the size of 2 input vectors, and yeah, so this is just a pairwise maximum. Yeah. It's not like a maximum value for all the vectors. So it's not like a one value, sorry, but it's a vector of same size as the size of the several input values. Well, and some statistical functions like mean, median, correlation, standard deviation of variance, and so on and so on. Well, rounding and informatical numbers. I'm just going to comment it rather than not to run another RStudio session. I'm going to crash all the computer. Well, around we have one number like 1.4. We would like to round it with a 0 and decimal digits, then the output is 1. If we have a number which is larger and 3 decimal places, we would like to round using two decimal places. The result is this. Yeah, it works like it should work. You know it from the rounding from the grammar school. And a kind of different operation than the rounding is the finding of significant digits. If we have a number like 1.458 and we would like to print it out using one single digits, it's print only 1. If we have 2 digits, round by this, these 2 digits, the first 2 digits are the same ones, similar to 3 and 4. Yeah. Just going to try to search for. It's going to work. I'll put it on this. It won't work. So, well. Sorry. Well, and the last thing is formatting, because there is a difference. If I would like to have, for example, this number 0.458 rounding, let's say, apply a significant function on this with considering 5 significant digits, then the result will be still this 1.458, not like the last signature. Even considering the fact that the last 0, if it's included in the reporting of a number, it's still significant there in for Biophysics. But it will be done by a significant function. It should be done by a format function. If you have a number 1.45 with one small number, it's not rounded. It's also not rounded. But if you like to include 3 and small numbers is just a number of digits which after the decimal separator, which will be included in the printing. If I am going to include 3, then the output is 1.450, and that's the way how we can include the last single digits in case that the last digit is a 0. Okay, so this is the way how it can be done. Okay, so guys, I'm going to end this session at this moment, because the only thing is we should do is matrices. I'd like to switch it to the next session, and we can just combine with the data frames and list, and then we will shift to some flow control features like cycles and warnings, because conditions, warning and error handlings and so on. So for this session, I think it's the end. If you have any questions, then you can email me. Email is here. I'm going to end. My email is here. You know my email. Thank you for your attention, or at least virtually. And the GitHub repository, you can find it here. So the link is here, and you can find the code and slides there, and also let's hope the rendering of this recording will work, so I can share it using YouTube. And the link to the YouTube video, the YouTube recording will be also at this repository. So this is like a key information for you, because you should find all important and related to this course in this repository online at this link. So thank you for your attention. As I said before, at least virtually. See you next time. Okay.